Student at a school is chosen at random, the probability that that student is in track is the same as the probability that they attended Bruintown last fall. The probability that a student is in track or attended Bruintown in 2018 is 0.68, 68%, the or. So let's go up here and just review really quick. What about and or? So when you see the or statements, so or of statements, or when you see the and statements, okay? When you see an and statement, you are going to multiply. When you see an and statement, you're going to multiply. When you see an or statement, you're going to take the probability of the first plus the probability of the second, subtract the probability of the third. And this subtracting part is going to be where do they have an overlap. So I'm seeing an or statement. I'm seeing an or statement. So what am I going to do here? All right, just keep this in mind. This is an or statement. What is the highest possible probability that the students chosen at random is in track? Okay, well, what do you know? You know the probability that they're in track is equal to the probability that they went to Bruintown. They're equal probabilities, okay? And the or statement equals 0.68, 68%. So that means when I add them up, so probability of track plus probability of Bruintown, subtract where they overlap. That's the and statement. Subtract where they overlap. We know that answer is 68%. Okay, what is the highest probability? Well, think of it this way. You have three options here. And I'd like you to draw these three boxes. They don't have to be very big. One box looks like this. They're never touching. One box has some overlap, and I'm going to color that in. And one box is, watch this, this is track, and watch, and this is Bruintown. For this particular word problem, of these three options, there's one option I get to cancel out. One option based on the fact that track, the probability of track has to be exactly the same as the probability of Bruintown. Okay, there's one option that's based on part A that I can assume I can cancel out. And then we're going to cancel out a second option. What is the highest possible probability? And that would be this one. Because in this case, if they're exactly the same circle, because track is equal to Bruintown, then what would the probability be for both? What would it be? Okay, so this circle, what would this circle be? And then what would these circles be? You know it has to add up to 68%. So let's do this one. Let's do this one. You right? Let's go to what I just heard Sam say. Sam suggested 34. Well, watch this. If this is 34% and this is 34%, this represents track and this is Bruintown. Do you agree that 34 plus 34, how much overlap is there? None. Do you agree 34 plus none equals 68? Yes? So here's one example, all right? But what about if they're exactly the same? What is this circle representing? Well, let's try 34 again. How much of this overlap is happening? What percentage if this is 34? If you believe this is 34, then do you think this is 34 plus 34 and there's a total overlapping minus 34? If you believe this is 34%, check this real quick. That means track is 34, Bruintown is 34, and then the overlap we have to subtract. Subtract 34. Does that equal 68? Is 34 plus 34 minus 34 68? It is not. What could this be? Turn to your partner. What percentage? Adrian, what do you think? 68%. Let's try 68, okay? So if track is 68 and they're equal, please do 68 plus 68 minus 68. What do you have done for an answer? 68%. And isn't that what this says this is? Yes. So here's the most we could possibly have. The highest possibility would be like this. And the lowest possibility would be like this. So what is the highest possible probability that a student chosen at random is in track? And the answer is the student could be 68% track, or 0.68. Track is exactly the same as Bruintown. What is the lowest possible probability that a student chosen at random is in Bruintown? So the lowest possibility is over here. This circle of the Venn diagram is track, this circle is Bruintown. And each one of these is worth what? 34%, or 0.34. Okay, let's do another one. Let's do this exact same concept right now. This time, let's do two concepts. Help me out right now, Christian. Give me one concept of something students could join at Trevor Brown. Avid, perfect. So everybody do Avid. We have Avid, or students that are involved in Avid or band. And I'm telling you that Avid or band, and we know that the probability of being an Avid is equal to the probability of being in band. And Avid or band is equal to 0.82. There's a large percentage of our students in this campus that are either in Avid or in band, okay? So keeping this in mind, what is the smallest probability that a student chosen at random would be in Avid? Work with your partner. What's the smallest possibility that a student chosen at random would be in Avid? Smallest means separated. Sam, what do you have for an answer? 0.41 is correct. So 0.41, and if you had to put it into one of those boxes where you have to bubble in down below and write 0.41, this is how you'd write it. If it was just a blank box and you could write in 41%, these are equivalent. So it depends how you can type it in. All right? Let's go with the next one. What is the highest possible probability that a student chosen at random is in band? So the highest possibility means that they overlap. And remember, we know they're equal. So this represents Avid, and it also represents band. Turn to your partner. What would that percentage be? Correct answer is 82%. Also could be written as 0.82. Going on to the next question. Next question is, I want you to analyze the options below in just a second. A high school hosts a science project competition for all the juniors and senior students enrolled in chemistry or physics. So everybody that's currently in chemistry and physics at this campus is going to be required to participate in the science project competition. And the top 3 contestants from Trevor Brown will move on to the district championship round, the top 3. But what are the students that are involved? Only students that are in chemistry or physics, and what grades do you have to be in? Junior or senior. Which set shows all the possible outcomes of winners with at least 2 seniors in it? So this represents first place, second place, third. First, second, third, first, second, third. So look at all your options, and with your partner, select the ones that contain at least 2 seniors of the 3 winners. Go ahead. I'm going to give you 20 seconds. Okay, are there 2 seniors here? Are there at least? The key is the word at least. Are there at least 2 seniors? Okay, there can be more. Okay, A could be a good option. Are there at least 2 seniors? Yeah. Are there at least 2 seniors? No. At least 2 seniors, at least 2 seniors. Oh, there's at least 2 seniors. At least 2 seniors, at least 2 seniors. Each one of these has 2 or more seniors. Thumbs up, thumbs down? Sarah, you're like picking at your thumb. What was your answer? What? Here we go. So this is going to get a little more complicated now. A student conducts a survey and finds the following information out about the student body at Trevor Brown. So at Trevor Brown, we are told that 46% of the population is male. 46% of the Trevor Brown student body is male. We're also told that 57, I want to make that a little bit clearer, 57% of the student body population does not own a pair of vans. The population percentage that is male and the population that does not own vans are independent. Based on this statistic, what percentage of the population is male who does not own a pair of vans? So what we're asking is, tell me what percentage is male and no vans. Male and no vans. So whenever we see the word and, what operation do we need to do? Multiply. So what is the probability of being male? So 0.46 times what's the probability of no vans? 0.57. Please multiply those. And this should be your answer right now, correct? And what if they tell you not to round? Then how would you write this as a percentage? 26.22%. 26.22%. If you didn't have a percentage option, you would just leave it as 0.622, okay? But here we have the percentage option. Church partner, make sure you understand. Although this is not, Ms. Robles, can I see you during advisory so you can get caught up, please? Yes. Although this is not, please listen, although this is not probability, this is one of the problems that you guys really struggled with on the rational unit, so I want to go over it. When you're asked to solve for r vex, like automatically people are trying to multiply by x plus 4 on top and x plus 4 on the bottom and cancel it. This is not a situation where you do that. All this problem says is when it says solve for r vex, they just want you to isolate this. So if you isolate this, what do you have to get rid of? You have to get rid of this. Now, right now it's negative. How do we get rid of it? We add it to the opposite side. Now we happen to be really lucky for this problem because we already have a common denominator. So that means we keep the common denominator the same and we push the tops together. We're adding them. And this problem is not factorable on top. There's your final answer. There's nothing more you can do. Turn to your partner, make sure you both understand. Bless you. This is genius. Okay, Deborah's a mom, and she needs to find a way to get her kids to help clean the house without saying this is exactly what you're going to do, okay? She wants to give her kids like some type of control over what they're going to have to do for chores. So she creates the spinner. Do you guys know what a spinner is? It's a circle. So she creates a spinner, and on her spinner, she has equal sections. It doesn't tell us at this time how many equal sections she has. We have to figure that out in just a second. And each section is going to have some type of a chore on it. So down below, she tells us what the chores are and how many sections would have those. So in total, how many sections do we have? So we're going to make up a spinner with 8 sections. So there's 4. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to do a little arrow here representing the spinner. Okay, so the first one, I'm just going to use labels here. Have one section be a garage. Sorry, not garbage. This is garbage. Should be garbage. And have another section be set the table. So T for table. And have 3 sections be dishes. Wash, dry, and put away dishes. And have 3 sections be wash, dry, fold clothes, and put them away. Just curious here. Which job would you prefer to do? Set the table? Easiest one? Which job would you not want to do? Oh, really? Oh, clothes are so much work. 4 people, you have to wash them, fold them, hang them. Okay, we're moving on. So here's what I have. And then they give me all these options, and it says which results best give evidence for the spinner above. So first, in order for you to be able to do that, you have to figure out, theoretically, that means it's not guaranteed, but in theory, what percent of the time will it land on the garbage? So to do that, how many of them are garbage? 1. So I'm going to take 1 and divide by the total number of sections, which is 8. So in theory, 12.5% of the time it's going to land on the garbage. And likewise, there's only once at the table, so 12.5% of the time it should land on table. This is in theory. It doesn't mean it's guaranteed it's going to do that. It probably will be close, but it's not guaranteed. There are 3 dishes to do. So in theory, 37.5% of the time it's going to land on dishes. And there happens to be 3 clothing. Wash, dry, fold, and put away. 37.5% of the time. All right, that's in theory. Now, what happens realistically? So I'm providing you with numbers below, and we're going to do the first, let's do this one right down here together. We're going to start with part C. I think it looks most unrealistic. So how do we see if this matches or is very close to the theory? So first you add them up. 3 and 3 is 6, 6, 7, 8. So I put an 8 on the bottom. Then I take 3 divided by 8. What's 3 divided by 8? Please do that once again. 3 divided by 8 is 37.5%. 3 divided by 8 again is 37.5%. I know 1 divided by 8 from doing it up above is 12.5% and 12.5%. And now I look above to see that's right. So I look at the garbage. Garbage should only be close to 12.5. Can everybody see how this is 37.5? Cross it out. It's not very realistic. Remember, it's probably not going to be exact, but it should be within like 5% probably. All right, with your partner, let's have you do A with a partner and then stop. It may or may not be the answer. Do A, please. Thank you. So I'm going to look at my results and look up here. So this is what I know. I know dishes and clothes should be considerably higher. Dishes and clothes. Are dishes and clothes considerably higher, because clothes is the same thing as laundry, is dishes and clothes considerably higher than the other two? Nope, cross out. Okay, now I want you on your own to see, do you think it looks like it's going to be B or D? Let's just look first. Make a prediction. Do you think it's going to be B or D by just looking? Why do you think B, Sam? Yeah, because dishes and clothes are considerably higher than these two, where dishes and clothes are actually smaller down here. Do me a favor and do these percentages just so we can see. Go ahead. Okay, what is the percentage for the garbage? You're telling me. Okay, what is it for table? Okay, dishes? And laundry. Okay, there we go. All right, let's go on right now and let's look at question number 6. Identify which question would best answer using experimental study, observational study, or a survey. What is the most popular musical artist among 16 to 18-year-olds? How do we figure that out? We ask people, we survey them. Part B, what is the average home value in Maryville neighborhood? Okay, we do some type of a survey to figure that out. How many administrators once taught a high school math class? We survey them and ask. How do 6-month-olds prefer to play? Do 6-month-olds prefer to play with stuffed animals or building blocks? What do? Observation. And last one, what is the effect of the amount of a brand of fertilizer on plants' growth? Okay, and that's going to be your experimental study. Okay? Thumbs up, thumbs down if we're okay with that. Nice job. So I'm going to read you the problem, and then you're going to do A, B, and C with your partner. Jenny rolls a fair cube. That just means it's a cube 1 through 6. Okay, it's a normal cube 1 through 6. And I'd like you with your partner. I'm going to time you, and I'm going to give you 3 minutes. I'd like you to do A, B, and C with your partner at this time. Ready? Begin. Yeah. Absolutely. How many of you plan to come in during advisory today to watch the lesson you have not watched? Hands up high. You need to be able to watch it. It's a 15-minute lesson. You have about 40 minutes left to watch. Hands up so I can save you spot. 1, 2. If you can't watch at home, then I'm going to ask that you come in, okay? Serge, I'm going to require that you come in as well because you haven't watched your videos from all the time you've been absent, right? It's due tomorrow. You have hours to watch from when you're gone. Yeah, that's one class period. You were gone for 3 or 4 days. Who needs another minute to finish all 3? I want answers for all 3, okay? Okay, let's get the first one done. What is the probability that Jenny rolls an odd number given? This is huge. Given that she rolls a number less than 4. So the given, that's the first part we start with. What are the numbers? I'm going to put 1 through 6 down. What are the numbers on a dice that are less than 4? Which numbers are those? 1, 2, and 3, okay? So out of those numbers, so there's the only numbers I start with. Those are the given. Now I go back to the top. Of these 3 numbers, so it's out of 3. Of these 3 numbers, how many of them are odd? 2/3 is the answer for the first one. Okay, next up is B. What is the probability that Jenny rolls an even or? What do we do with or again? What do we do with or? We are going to add and then subtract. We are going to add, and then subtract. Okay. So what's the probability that it's even? So how many even numbers are there on 1 through 6? How many even numbers? There are. So there's 3 of 6 are even. And how many of them have numbers that are greater than 2? Greater than 2 would be a total of So 4 over 6. How many of the numbers are both even, which is right here? How many of them are even and also greater than 2? 4 and 6. Subtract 2 over 6. Okay, grab your calculator. Put this in parentheses, please. 3 divided by 6 plus 4 divided by 6 minus 2 divided by 6. Okay, turn it back into a fraction, and the correct answer is 5/6. What is the probability that Jenny rolls an odd or a number greater than 3? Odd or greater than 3. Let's actually change this. Let's do the one that's and. Let's change this to and since we haven't had it and. What is the probability that Jenny rolls an odd and a number greater than 3? So with and, first, what's the probability that it's odd? How many of these numbers are odd? 3 out of 6. With and, we multiply. How many numbers are greater than 3? 4, 5, and 6. So there's 3 numbers. Please multiply. 3 6 times 3 6. Then hit math fraction, enter, enter to reduce it, and you end up with an answer of, is it 1/4? 1/4. Okay, moving on to the next problem.